Right, now November 2017, question 10. Thanks for tuning in. Question 10, it's about my electric circuit. So Lana, I'm given 3 resistors in this circuit, 6 ohm, 15 ohm, as well as the R, which is unknown. Ngibane current through the circuit, a power source, as well as a voltmeter across resistor R. Now 10.1 bati, the circuit below consists of a 6 ohm and 15 ohm resistor connected in parallel and an unknown resistor R in series. So this parallel connection is connected in series with this R resistor. The 6 and the 15 are in parallel. Né? And then an ammeter, a high resistance voltmeter, this one, a closed switch and wires. A closed switch and battery are connected as shown. The resistance of the battery and wires can be ignored. Voila. Okay. The total power dissipated in the parallel part of the circuit is 50 watts. So Lana, basically, but for this parallel connection, we have iloganj, or let me say the parallel connection is using 50 joules per second. That's another definition or another unit for iloganj, power, which is what is joules per second. So this parallel connection uses 50 joules per second. So or in neither the absorber from the circuit, the absorber 50 joules per second, because the power source is supplying energy throughout the circuit. So this parallel connection is absorbing or using up to 50 joules per second. And then basically I would 10.1.1 but define the term power. There's a reason why I was playing around with the 50 watts, 50 joules per second. It's actually a definition of power. Power definer is what again? Power is the rate at which work is done or energy is transferred, right? So a definition of power, and then 10.1.2 calculate the effective resistance of the parallel connection. The effective resistance of the so for the parallel connection, it's a giveaway or activity 1 over RP. The P stands for parallel. Max bagu power now. So parallel connection, this is how we calculate the total resistance. So it's 1 over 6, 1 over 15, 1 over RP. So 1 over RP is equal to, let's calculate. So Lana, we have 1 over 6 plus 1 over 15 is equal to 70 over 30. 70 over 30, since ngifuna RP not 1 over RP, swapha la ngithi 30 over 7 is equal to 30 over 7 is equal to in 3 decimal places is 4,286 ohms. So this is the value for the total effective resistance of the parallel combination. 10.1.3 calculate the potential difference across the resistors in parallel. The potential difference across the resistors in parallel. What are we given now? Power. Okay, Well, since I'm not current in the circuit, I can't use ohms law to calculate potential difference, but instead I need to use the power, since it's the only value enginayo to calculate, or let me say it's the only data abangiphe yona to perform my calculations, including nalama resistors lawa. So data, let's start off with the data. I have power, and this power is across the parallel path, ne? So it makes sense with the 7 say this given power. And then what else do I have? Resistance. The total resistance in parallel is 4,286 ohms, right? Ohms. Now I think keep a guy formula sheet la. So I'm given a power. I just calculated the total resistance for the parallel part. What do I want? Ngifuna uV, the potential difference across the parallel connection. So we need a formula of power where there's V as well as R. Power equal to nope. Power equal to nope, I don't have a current. Power equal to I don't have a current, so I can't use this one, but instead ngizosebenzisa this one. I have power R, I want the value for V. Ngifuna i-value ka V. Alright, so P is equal to V squared over R. Then you substitute what's the value for P? 50 VR divided by V squared R1 4,286. Then you cross multiply. Then I cross multiply. I think qhubekele ngapha ngizothi V, okay, V, I think lenze lonke le calculation. V is equal to 50 times 4. V is equal to the square root of 50 times 4,286. So therefore V is equal to 50 times 4,286 equal to, it's what? It's 14,64. 14,64. So that's our answer for this one. 14,64. So how about C round off? Right. 14,64 volts. This is our final answer. Now with 10.1.4, calculate the current through resistor R. I think eraser la. 10 it's 10,1.4. let's calculate the current through resistor R. Through resistor R. So ngifuna current lapha, and then ngayichaza ngithini? Okay, bheka, since R resistor R, and then this parallel connection 6 as well as 15 ohm, they are connected in series. This one and this one are connected in series. So bheka ke manje, for this connection, for this combination, this parallel combination, nginani, I have a voltage ngicede ukuyicalculate. It's what? 14,64 volts, right? 14,64 volts. Bheka ke manje, in a series connection, right? I know that the current flow la is the same as the current flow la, because the current remain a constant in series. The only thing ever divided is the potential difference. So by calculating the current flow through the parallel combination, automatically singithole the current flow through the R resistor. So in this way, we're just going to calculate the current flow through this parallel combination. Then is over our answer to this question 10.1.4. So sizowenza so sebenza Ohm's law, current is equal to V over R, right? So the current is equal to so sebenza the total effective resistance for the parallel connection. So therefore V is 14, formula right, mar. Let me check. Ohm, now resistor, V infinite current. Okay. Infinite current, masala. Infinite current. I write, man. I write the formula. So now it's 14,64 divided by R total resistance is what? Is 4,286 equal to, let's calculate, 14,64 divided by 4,286 is equal to 3,42 amperes. So this is the current flow through the parallel connection as the IP. So therefore the current through the parallel connection is same as the current through the R resistor. So therefore IR is equal to 3,42 amperes. So this is our answer. And then see pendula the next question. The switch in the circuit is now opened. Boom. Sfulale switch le manje, right? How will the reading on the voltmeter be influenced? How will the reading on the voltmeter be influenced? Choose from increase, decrease, or remain the same. Okay, these will remain the same. I'll explain why. It will wait. Iso decrease at this thing, not remain the same. Decrease. So on such questions, 10.1.6, on such questions, nangabe uzowaphendula ama-questions afana nalawo ku-electricity, ne? Kuma-electrical circuits, kwamele ulokanje refer to the Ohm's law. Yezo explainer everything. So lana mawuthatha ukubheka, if the switch opens up la, the circuit loses a resistor. The resistor yaka 15 fana nokuthi ayisa exist or it's out of the circuit ngoba current anyeke isa flow through this 15 ohm resistor because of current discontinue la at this opening la, right? So the answer to this one, it's because of total resistance increase, right? So for this parallel connection, the total resistance was what? Was 4,286 for this parallel connection. So if 15 agasekho, the total resistance for this parallel connection or this former parallel connection seku 6 manje. If lo 15 agasekho, it means the resistance for this connection sekuba ubani 6. So therefore the resistance increase, and R plus 6, it's more than this 4.286 plus R. So the total resistance does what? Increase. Let's go back to the formula sheet here to Okay, let's use this one. This is Ohm's law. R is equal to V over I. Let's use this formula to explain that. If your resistor here increase, right, what happens to a voltmeter reading? It also does what? It also increases. So therefore, the current in the circuit, the voltage does what? It increases because of the total resistance increases. It increases. Or let me explain it. Let me say, since the total resistance for a circuit increase, and it increases because of the 6 ohm resistor esithola la ku parallel connection. So the potential difference across this 6 ohm resistor is increase now because of the increase in resistance. So therefore this value is decrease. And now this one, what's the question? The reading on the voltmeter, how will the reading on the voltmeter be influenced? So a higher resistance go series connection, a higher resistance in the series connection will take up more energy, or it will require more potential difference. So therefore this one is yes, the voltmeter reading will drop, and then this one is increase. Or another way of explaining it, the total resistance increase, therefore the current for the circuit does what? Decrease. Therefore, since R will remain a constant, it also means with the resistance potential difference is decrease as well. So that's the answer for 10.1.6. 10.2 and 10.2 bafunani ke la. Okay, but a geyser labeled 200 watts, 2000 watts is used for an average of 5 hours per day. The cost of electricity is 80 cents per kilowatt. Okay, lana, it's cost of electricity here, this question. Wasinikeza igeyser, sifuna ukwazi ukuthi isebenza how much, like sispenda, bafuna ukwazi ukuthi if uzosebenza this amount of if uzosebenza igeyser eyidinga this amount of energy for an average of 5 hours, and then the tariff naye basiphe yona la, the tariff, the cost of electricity tariff uphiwa ilo kanje municipality, uphiwa sometimes uphiwa ilo kanje i-Eskom. It depends ukuthi ilo guy i-electricity yakho i-supply ngubani, municipality or i-Eskom. So lana basiphe as well as the tariff. Now 10.2.1, but they calculate the energy used by the geyser for 5 hours per day. So sifuna ukwazi ukuthi i-consumer energy engakanani kuqala. Let's calculate. So formula sheet, we want to know the energy. The energy is represented as W in this case. So W is equal to, I have what? Time. Let's keep it data kuqala. Time is equal to 5 hours. 5 hours, but asebenzi ngama hours kulo kanje ku physics. We need to convert this to seconds. So it's 5 times 60 times 60 inginikeza 18,000 seconds. 18,000 seconds. Voila. So ngifuna calculator. What else am I given? I'm given power. Power is equal to 2000 watts. 2000 watts. Ngifuna the amount of work or energy used. So W, ngifuna a formula N, P as well as T, so that I can calculate to W. What else? Do I have a resistor now? Nah. Okay, W is equal to, this one. This one. Work over time. So P is equal to W over delta T. If I calculate the amount of work done, I have power and time. So power is what? 2000 equal to amount of work divided by 18,000. Now cross multiplier and total with the work is equal to 2000 times 18,000. So the amount of work done is equal to 2000 times 18,000. Wow. Oh wow. Okay, how about I'm gonna zero now. That's where this thing comes in again. Remember? That's where this thing comes in. The ishrinka inumber yakho to scientific notation. So singayisebenzisa this value 36 times 10 to exponent 6. Angifuna ukubhala la ku-0 abangaka. I might miss a 0 lapha. So it's much better now when you bala. So or the conventional way is this one times 10 exponent 7 joules. This is the amount of energy done or transferred or used. So this is our answer now. 10.2.2 bathini ke manje. Okay, now 10.2.2, calculate the cost of electricity to operate the geyser for a month with 30 days. Okay, for this one I think it's so 10.2.2 for a month. So the cost is equal to kilowatt hour times the tariff. Okay, ngifuna ukubhala tariff la. Tariff times the tariff. So kilowatt hour times tariff. Okay, bheka ke manje, this geyser operator for a month with 30 days, right? And it's the operator for how long? For 5 hours per day. So the total time ngizosidinga lesikhathi lesi, the kilowatt hour bangiphe yona lapha. Wait, no, bangiphanga yona kilowatt hour. Kumele ngicalculate now. So the kilowatt hour hour is equal to 2000. Remember, it's kilowatt hour, so the units are going to be kilowatt hour. So the watts komele divided by 1000, you thola ubani u2, you thola u2. 2000 divided by 1000 is 2 times kilowatt. Sengnayo, I need the hour. How many hours? Is 5 hours. So my answer is equal to 2. It's 10 kilowatt hour for a day. Right? Since sifuna ukuthola i-cost for the whole month, it means this value komele ngi-times ngobani? Ngo-30. So it's 10 times 30 is what? Is 300 kilowatt hour for a month, for the entire month, right? For the entire month. Now the cost is over equal to 300 times the tariff of 80 cents. So it's 300 times 80 is equal to what? 24,000 cents. 24,000 cents. But it doesn't make sense. Angrime, but angrime la ne. 24,000 cents. It doesn't make sense with the answer here to ibe in cents. Like it's much better if she express her in rands. Yeah, if she express her in rands. So the 24,000, we know how many cents. We know how many cents go 1 rand. We know 100 cents. So you divide on 100 la. The answer is ophuma is over in rands. So it's 240 rand. So this geyser, to operate this geyser for a month of 30 days, it means that we patala 240 rand. But this is South Africa, man. Inflation, the cost of living is too high, man. Operating a geyser for 5 hours, especially like South Africa, well, this is not a true reflection, but it's way more expensive than this. The reality shonjalo. In reality, it's way more expensive than this. So lana is just a problem for this exam. So yeah, thanks for watching. Video etiphelela lana. Thanks for watching. Now we enjoyile. Leave a like. Nangabe interested kwamanye ama questions akhona kule question paper. Check out the description below uzothola ama links. Nangabe une question, leave it in the comment section. Let's talk. Yeah, thanks for watching, guys. Asibonane kule video elandelayo. Bye bye.